The sum of an arithmetic series, and also sigma notation. You need to be able to work out the sum of numbers in an arithmetic sequence. For examples, add up the numbers from 1 to 100. You could sit down with a calculator, you could sit down with a pen and paper, or you could do, if we write them in the right order first, 1 plus 2 plus 3 plus 4 plus ... then write the sequence backwards, 100 plus 99 plus ... 3 plus 2 plus 1, and then add the two series together. So 2s is 1 plus 100, 101, 2 plus 99, 101, 3 and so on. You end up with 100 101s. So 2s is 100 101s. So if we divide that by 2, which we can do in our head, s is 5050. This method was discovered by Carl Friedrich Gauss, who lived between 1777 and 1855 whilst he was still in primary school. As a general rule, we can do this. If we have Sn is a plus d plus a plus 2d plus a plus 3d plus ... a plus n minus 2d, the penultimate term, plus a plus n minus 1d, the final term, and write that series backwards, and then add the two series together, we get two lots of Sn is a plus n minus 1d, or 2a plus n minus 1d. A plus d plus a plus n minus 2d works out the same. Group the a's, 2a plus n minus 1d. In fact, when we add all the terms together, we get 2a plus n minus 1d's. In fact, we get n of them. So we get n lots of the same thing. So we can write it in shorthand, n 2a plus n minus 1d. Then just divide by 2, n over 2, 2a plus n minus 1d. The good news, that's in the C1 formula book. The bad news, you might possibly be asked to do that proof in the C1 exam, so you have to know how it works. Also, if you think what's there, 2a plus n minus 1d, if we rewrite the 2a as a plus a, then a is the first term and a plus n minus 1d is the last term. So n over 2, a plus l, can also be used as a formula for the sum of the first n terms of an arithmetic series. Calculate the value of the first 100 odd numbers, 1, 3, 5, 7 and so on, where the first term is 1, the difference is 2, the number of numbers is 100, plug it in, 100 over 2, 2 times 1 plus 99 times 2. We can then work it out. The first 100 odd numbers adds up to be 10,000. 50 times 200. The 100th term, well, using our nth term formula, a plus n minus 1d, the 100th term is 1 plus 99 times 2, 199. So using the other formula, Sn is n over 2, the first term plus the last term, 100 over 2, 1 plus 199, the same answer, 10,000. Find the number of terms needed for the sum of the following sequence to exceed 2000. 4 plus 9 plus 16 plus 19. Well, Sn needs to be 2000. A, the first term is 4. D, the difference is 5. There's our Sn formula. Plug all the numbers in. 2000 is n over 2, 8 plus n minus 1 times 5. Multiply by 2. 4000 is n, 8 plus 5n minus 5, tidying that bracket up as well. Group the terms together. 3 plus 5n is now inside the square bracket, times the bracket out. 5n squared plus 3n, rearrange. Nothing is 5n squared plus 3n minus 4000. So we end up with a quadratic. Now solve that quadratic. It doesn't factorise, but we can use the common formula to get that n is either 27.9 or minus 28.5. Again, being a sequence, the minus one makes no sense. We need a whole number of terms in our series, so n must be 28. As soon as you get the 28th term, then you've exceeded 2000. The symbol sigma, that's a capital sigma, can be used to mean sum of. So if we had that, that's telling us it's the sum between r's between 0 and 10 of 2r plus 2 plus 3r. So we have the first value of r, the highest value of r, and the formula to be used for our sum. So this means sum of the sequence 2 plus 3r from r is 0 to 10. i.e. when r is 0, 2 plus 3r is 2. When r is 1, 2 plus 3r is 5. When r is 2, 2 plus 3r is 8. And when r is 10, 2 plus 3r is 32. So it's the sum of all of those. Here, it's the sum between r is 5 and 15 of 10 minus 2r. So 15 is the highest value. 5 is the first value of r. That's the formula to be used. So we can plug our numbers in again, 0 plus minus 2 plus minus 4 up to minus 20. The sigma notation is used an awful lot in the maths coming up. To calculate the value of the following series, r between 1 and 20 of 4r plus 1. If we put the r's in, when r is 1, 4 plus 1 is 5. When r is 2, 4 lots of 2 plus 1 is 9. When r is 3, 4 lots of 3 plus 1 is 13. All the way up to when r is 20, 4 lots of 20 plus r, which is 81. So the first term is 5, the difference is 4, n is 20, there are 20 terms altogether. We've got the sum of the first n terms for an arithmetic series. The formula is in the formula book, n over 2, 2a plus n minus 1d. We can substitute in our values. We can find that the sum of that series is 860.